Welcome to another video podcast. In this episode we're going to be taking a look at calculating areas again, only this time we're going to compare and contrast integrating vertically with integrating horizontally. So I have two graphs on the left hand side, both are the same, both are defined by the curves given here as y squared equals x minus 1 and x minus 3. However, in the top picture I'm going to want to try to do this integration vertically. So I'm going to do sort of our standard vertical integration for this picture, and in this picture below I'm going to approach the problem horizontally. And so I want to compare and contrast the two styles. In the case of the vertical integration problem, I have to decompose this area into two regions. I need area 1 and I need an area 2. Now, my reason for that is very simple. If I'm inside area 1, then the top function and the bottom function are consistent throughout. In other words, any place I try to make a vertical line through area 1, the top function and the bottom function are the same. It changes here at this intersection point, which we'll need to find, and in area 2, the top function stays the same, but now the bottom function has switched to the blue function, which is x minus 3. Now if I'm integrating vertically, remember that things need to be in terms of x. So this is integration in terms of x. Given the functions we have, this is y equals x minus 3, so that's written in terms of x, but the green graph is currently written as a function of y because of the y squared. If I take the y squared and I solve for just y, then clearly y is plus or minus the square root of x minus 1, with the positive square root being the upper branch and the negative square root being the bottom branch. So if I'm trying to put together an integral, and I'm just going to set up the integrals here, I'm not going to evaluate them, but if I'm trying to set up an integral for this particular graph, then it's composed of what happens on area 1 plus what happens on area 2. Now, the other point of consideration here is what is this intersection point? I need to know that point. Clearly from the graph it looks like it happens at 2, but we can't judge it based on the graph. We actually need to go ahead and find it. So let me go ahead and do that off to the side. We'll be able to use it again down here for this other one, but it's where these two graphs intersect. So it's where y squared equals x minus 1 and it's where y equals x minus 3. It's where the two are the same. Now, in order to compare them, it's going to be best that we have something common to substitute in and set equal. For example, if I take y squared equals x minus 1, I can rewrite this as x equal y squared plus 1, and this can be rewritten as x equals y plus 3. Now I can set the two x's equal to each other, and so I can go through this and solve by setting y squared plus 1 equal y plus 3. Doing a little bit of algebra here, I can quickly arrive at this answer. So that would need to be 0, which implies that, let's see here, we should get a minus 2 plus 1. That's how it factors. So the two y points at the intersection are y equal to 2 and y equal to negative 1, which you can see in the graph. The y equal to 2 point is here, and the y equal to negative 1 point is here. But since I'm integrating vertically, I don't need the y values at those points, I need the x values. So if y is 2, and I plug it in, let's say, to this one, then x would be 5. And if y is negative 1, plugging it into this, x would be 2. So the x value here is 5, and the x value here is 2. So that's everything we need for this particular example to go ahead and do the integration. We've got our first area, area 1. Area 1 stretches from x equal to 0 up to x equal to 2. The function on top for area 1 is the positive square root, and the function on bottom is the negative square root. So it's top minus the bottom. So this tells us area 1, plus if I now look at area 2 is starting at x equal to 2, and it finishes over here at x equal to 5. So it ranges from 2 to 5. The top function is once again the positive branch, and the bottom function is the line x minus 3. So at this point I'm pretty happy with it. I do notice that the top function here can be written, or the area 1 can be simplified a little bit. This is simply 2 square root of x minus 1. And the bottom function, I can drop the parentheses here and write this as the integral from 2 to 5 of the square root of x minus 1 minus x plus 3 dx. And so this is a good form to leave it in. I'm just setting up the integral here. No, that's not a very good rectangle. Let me try that again. Just setting it up again. This is the answer I'm looking for. So at that point I feel comfortable with that answer. Now let's go ahead and find it horizontally. If I'm looking at the bottom down here horizontally, in the case of horizontal integration, I'm making horizontal lines. So all my lines look like this. All my rectangles I'm trying to create look like this. Notice that in each and every case, the line has a consistent left-hand side and a consistent right-hand side. In other words, the blue function is always the right-hand side and the green is always the left-hand side. This is a decided advantage for this particular problem because it allows us to get away with only doing a single integral. Now remember, with horizontal, y is what we're integrating with respect to, so these two intersection points now, y equal to 2 and y equal to negative 1, give us our limits. So the area in the case of integrating horizontally would range from negative 1 up to 2. Those are the y values involved. And remember, for horizontal integration, it's always right minus left. And so the right function in this case is, I have to write it as a function of y, and as a function of y, the right-hand side is y plus 3. And as a function of y, the left-hand side, we have it right here, is y squared plus 1. And remember, I'm integrating with respect to y. So if I simplify that up a little bit, get all the good pieces in there, I'll end up with minus y squared from this piece plus y plus 2 dy. One thing I want you to take a look at here is, in doing the horizontal integration step, the integrand here is the negative of this. And that is usually going to be the case. In fact, if I wanted to, I could multiply through by a negative here without really changing the problem, and I would get exactly that integrand. So it's just something to keep in mind. So this is the other potential answer. And I'm okay with either of these two answers for this particular problem, although the horizontal one is quite a bit easier. It's also quite a bit easier to do the integration, so keep that in mind. And just for a little bit of practice here, I would encourage you to go ahead and confirm that the area in both cases is equal to 9/2. So that's our area for this problem, a total of 9/2 area. You should get the same answer regardless of whether you integrate the black rectangle or the purple rectangle. Either the vertical or the horizontal should give you the same answer. So I'd encourage you to go ahead and check that in your work. Alright, thank you for watching this episode.